We have example here. Just a moment. So I have pinned you a query in the chat. Can you just copy that? Yeah. So before working on the query in the DBT, so let's go to Snowflake and see what does this query do. So can you just go to Snowflake and copy this query? So here, so we do have a query, so which has 3 cities for that. Okay, first city. So can you just go up? So everybody can see the screen.
Yes.
You can see.
Okay. Yeah, if you see the first city, so these all just one query. Okay, so here we are trying to make use of 3 cities. Okay, first city is customer, second is orders, the third one is customer orders. Okay. So can you just give me some control, Ravi? Okay. So if you see, this is our first city. So which for this city, the underlying table is we are using the customers table here. So we are just prepping up this data. So we are just shaping up this data. I mean, we just change the column name here, alias name, and same as that. So the second city is orders here. So the underlying table for this order city is again the orders table available in the Jaffel shop schema under raw database. Okay. So and in the final city, in the third city is customer orders. Okay. So here we are making use of the order city, which we have created earlier in the previous query in the previous city. So here we are just aggregating the data based on the customer ID column. Okay, we are just finding out what is the minimum order. I mean, what is the last first order date for the particular customer, and what is his recent order date, until now how many orders he has given. So these are all the things. So we are going to get in this third city. And if you come to the final city, so we are just using the left join to join the customer orders and the customer table. to give his complete detail of the customer, like his ID, his name, and his recent order details. So we have everything here. And finally, so we are just doing the select star from the CTE. Okay. Is it clear? Anyone has any doubts in the CTE? No. Okay. Let's try. I'll just show you. I'll just quickly executing one by one. So these are first city which you have given. Okay, and this would be second city. So individually also you can run these things. I'm just running the underlying query for every city. In the second city, we have order ID, customer ID, order date, and status for each customer. And as like I said, the third city, so we are just aggregating the data by customer ID here. Okay, since we don't have the city ready, so it is showing as an error. Okay, and even though just like that, the final query also won't execute because we are using the CTs inside that. So let's execute the whole query here. So this is how our final data set looks like. So for every customer, so we will get his first name, last name, and his first order date, and his most recent order date, and the number of orders he has placed till now. Okay. Is it clear? So the same query, so we are with the same query, so which has all the cities. So we are going to create our first model here. Okay. So which is the DBT here? Ravi?
This is the one.
Yeah. So in the last class, under the models folder, so we have created a file. So let me show you how to create a file again. So you just have to go to the models. So you see this ellipsis symbol, the 3 dots. Just click on that. You will get an option. You'll just get an option, create a file here. Okay. You can just click on that and you can give any name, whatever the file you want to create, you can just give the name here. So and always for the models, the extension should be .sql files. Okay. So whatever the SQL for whatever the .sql files that we are going to create, so those SQL files are going to act as a models for us. Okay. Inside those SQL files, so we will be writing our transformation logic using the select statements. Okay. Clear? Okay. Since we have already created one .sql files here, which is customers. So I'm just placing the same code here. And our final statement could be, we will be selecting the data from our final CTE here with all the, after all the aggregations and reshaping of the data. So I'll just be selecting the data from there. Okay. Is it clear?
So both sides we need to create the same query, sir?
No. So in Snowflake, we don't have to create the query. So I'm just showing the how the query works in the Snowflake. That's it. So here also, so before saving the query, so before saving it, saving this model, so you do have an option of preview here. So you can just click on the preview. So the DBT will directly connect to the Snowflake and fetch the data from there for those underlying tables. Okay. So if you see the same result set, so whatever we have got from the Snowflake side, the same results you can see here. Okay. Is it clear? So we are just doing the preview here. Okay. So we are not building any models. Okay. So with the click of preview, so only DBT will just connect to Snowflake and give you the glimpse of data. It is not going to actually materialize things or create any models. Okay. Is it clear?
Yes, sir.
Okay. Just click on save here. So our model is now saved. Okay. So to be able to create the models or this model and to be able to materialize this model in the Snowflake, so we have to run this SQL file or we have to run this customers model. Okay. So to be able to run that, so we have to give the command dbt run. So this is the command which we use in dbt to run our models. Okay. So here, if you see at the bottom of the screen, so you have the option to give the comments here. Here you should write dbt run. Okay. So I'm just click on enter here. Has failed. This one has failed.
अच्छा काय करूया काय करून घेतलं
इथं हे करून घेतलं त्याला
अच्छा एवढं का
प्रॉपर कट करून त्याचं हे करून
Sir,
केलं.
actually semicolon is not required, I think. Whatever file you ping me, there was no semicolon.
Where was the semicolon here?
No, I
This
gave.
last one.
बस दिसायला ना
हो
Is that required?
काय झालं पिलू पोट दुखतंय का शिजेचा त्रास होतोय का नाही शी करून घेऊ ना आपण चल ना मग ते पोट छान साफ झालं का काहीच वाटत
Guys,
नाही
please go on mute.
ते इथेच पोट आलंय.
wait.
Mute, please.
Voice not coming.
Sorry. Yeah, so I was not talking about it actually. So I just remove the semicolon from there. Okay. So if you see our customers model is now successful. So along with our customers model, there were other two example models in the example folder here. So you can just ignore them. So along with those models, so we can see our customers model also have finished now. Okay. So and if you just expand the customers model, and if you just go to the details here, so we can see what kind of DDL our DBT has submitted to Snowflake. Okay. So if you see here, it is starting with create or replace view. Okay. So since we have not given any what kind of materialization it has to do, so it has by default taken view. It is going to create a view out of our model. Okay. So the definition of our model would be the transformation logic which we have given. Okay. Let's go to Snowflake and just refresh things.
So what was the error, sir, that we got?
So I had this semicolon here.
Okay.
So that's what giving me the error. Okay. So if I go to the analytics database and go to the views here, so you can see the model customers created here. Okay. You just see the definition. So the DDL of that particular view looks like that. Okay. So this is what I was saying. So when I say DBT will take care of all the DDL part here. Okay. So this is with just the transformation logic we have given. So it is going to create a view. So it has taken these columns. So it will take whatever the columns are coming out of the model. So it will take those columns and it will create a view out of that. Okay. And it will just, for the definition of the view, it will just use the transformation logic which is given by us. Okay. Is it clear?
So we can do it the same thing in the Snowflake, sir. So how it is useful?
No, same thing as
Same thing we can do it in the Snowflake also, right?
yes, same thing you can do it in the Snowflake. See, the hassle here is first of all is the cost thing. Okay. And the next one is you yourself has to write all the DDL and DDL things. Okay.
Yes.
So the first one is question mark, that is the major one. So next one is you have to write your, so whatever the intermediate tables that you are going to use. Okay. For all those intermediate tables, you have to create your own DDLs. Okay.
Okay.
So that is the major hassle here. So that things we are trying to avoid here.
Okay. That
And
means
major thing
writing
is
in
we
the
are trying
DBT,
to,
right?
sorry.
Those things we are writing in the DBT.
Yes. So in the DBT, we are just writing our select statements. We are not going to focus on our DDLs here. Okay.
Okay.
So we are not worried about any data types, anything.
Okay. Okay.
So DBT will be taking care of that. Okay. Any doubts? Okay. So if you see along with our customers model. So we have another more, we have two more also created. So the example ones, the my first DBT and my second DBT models, those are also got created along with that. Okay. And one more thing, if you see here, so while running so I'm going to run the DBT run command again. So if you clearly observe, so for only two models will start created first, which is the my first DBT and customers model. And after that, after a few seconds, the my second DBT model is going to start it. So why this is because of the dependency between the example models. Our customer models is an independent one. Okay, it is not dependent on any other model, right? But the my second DBT model, which is an example one, is dependent on the my first DBT model. Okay. So first, what are all the independent models are available, independent SQL files are there. So only first those will run. After that, so the dependent models will run. Okay. So there is a dependency between this my first DBT and my second DBT.
So, but in the first DBT model, it is created as a table, right? Is there any? There is no logic there. It's a direct table, is it?
Yes, it's a direct table. So we have to give some instructions to the DBT such that it would create as a table. So we are going to talk about that next. Okay, we'll see that. So if you're not giving any instructions, so by default, it will be created as a view. So if you want to be created in a different way, so there is a logic, so which we have to put in the DBT code. Okay. Any doubts here? Hello? No doubts? Okay. So now let's see if we want to build this customers model as a table. So right now, if it is created as a table, right? It is created as a view. Okay. Let's see how we can create as a table. So to be able to do that, so we have to add something called config block here. Okay. So on top of the code which we are using in the model, so we have to add something called a config block. So which will give the DBT the instruction that it should be created in such the way, so which is configured in the config block. Okay. So config block usually starts with the flower brackets. Okay. So we should write config, and then open braces, you can give materialized equals to table. So the table, the keyword table should always be in single quotes. Okay. So this is how the simple config block which we should give in the SQL files. So if you want to create that as a table, not as a view. Okay. Any doubts here? Okay, fine. So let's go ahead and save this. Just saving this. And let's try to run this DBT model again using DBT run. Okay, so model is successful. Now let's go ahead and go to the details, the summary, and if you come down, so you can see that. So the DDL which it has submitted has changed. Now it is submitting, it is trying to create a transient table here. Okay, so by default, it will be creating a transient table here. Okay, so the definition of that table would be same, whatever the transformation logic we have created. So it will be using as the definition. And only thing is that instead of creating a view, it will create a table for us. Okay. So right now I can see it has created the table. Let's go ahead and refresh the Snowflake data warehouse and see the changes. Okay. So if you see, the model has recreated the customer's view. Okay. So now whatever the view that was created earlier is now removed and it is now created as a table. Okay. Is it clear? So if you see the definition, so this is the DDL part which DBT has given the Snowflake. Okay. So with this DBT, so our table would be created first. Okay. Any doubts here?
So sir, in the DBT also we are writing the code, and the same thing also we can do it in the Snowflake also, right, sir?
Yes, that's what I told earlier. So in Snowflake, you have to write your own DDLs.
Okay.
So in DBT, did we write any table definition here? And did we write any create table column names or any data types for those columns? Did we write did we discuss anything on the DBT?
But we writing as a select ID as a customer ID, first name, last name.
Yes. So yes, that is the transfer logic we have written. But to be able to store the data, so you should either have a table or a view, right?
Yeah, by default is a view. Suppose if you mention as a
No, I'm not talking about the default things. Okay. See, with the query which we have given here, so whatever let's say this is our query. So this query will give you some data, right?
yes.
So where will you store the data? So if you want to pass this data to some other thing, so every time you keep on using the query, you keep on putting these big queries in your other, I mean, if you see, if you are using some ETLs, so every time you keep on adding the logics to the particular query in each step, or you are going to use some intermediate tables or views.
Yeah, intermediate. Yeah.
Yeah, something you have to use, right?
Right.
So in each step, you cannot keep on adding the logics to the same query and making it more complex, right?
Okay, got you.
Okay. So in Snowflake, I mean, that's what I told. So based on the cost and the time, so to think of the logics, we do not have to worry about the DDL part here. Okay.
Okay.
Yeah. So we just have to give the logic for that. We just have to write some simple select statements in DBT. So whatever the logic it has created, whatever the DTL, it has to submit based on our transformation logic. So that will be provided to the Snowflake like this. Okay.
Okay. Thank you.
Okay. So earlier in the first run, so our model has been created as a view. So it has submitted the detail like create or replace view. Now, since we have added our config block to giving the instructions that our model should be created as a table. So now DBT has removed that view. It has recreated the same model as a table here. Okay. Is it clear?
Yes.
Okay. So, and one more thing is, so every time, so we have noticed every time I just do the DBT run. So let's say I have only one SQL file now. So if you have like more models like this, more such models, every time you do the DBT run, every time DBT run command runs, so all the models will be recreated. Okay. So to avoid that, so we can only select only one model just to run. Okay. So whichever the model we want to run, we can run that particular model here. Okay. So for that, so we have to use DBT run --, select customers. Okay. So instead of using I mean, there is no need of using the .SQL here. So because customer, we just have to give the model name. We have to write DBT run --, select customers here. Okay. Just run that. So if see, so only our customer model has been run. So the other two models are not recreated. So every time we do this DBT run, so our table will be recreated. Okay, we'll keep on recreating. Is it clear?
Yes.
Now, so we we are going to talk about the concept of modularity and reference functions here. Okay, we by using the same example. Okay, so if you see here in our first example, so we have used multiple cities here. Okay, so in the first city we have some underlying, we made use of some underlying table customers and shaped, I mean, and we shaped it the way we want. Okay, same as in with the order city. So we did the same thing. So we have changed some, I mean, since we don't have any complex logics, we are not going to run any complex logics. So whatever the things I've used as alias names, so the only that thing I'm talking as the shaping. Okay, so if you have some additional logics, I mean, if we have some complex logics, we can put that. Okay, so I'm just talking about shaping of the data here. Okay, so if you have some complex logics, you can put that. Since I don't have any complex logics, I'm using very simple ones. So I just changed the I'm just using the alias names for the columns. Okay, so in the same likewise in the order city also, I'm just using the orders table from Jaffreshop as a base table and just shaping of the data like the way I want. Okay, and for the other order also we just did some aggregations, and finally we have some tables that is coming out of our model from the final CT. Okay, So let's say, let's take an example of the building of the cars. Okay. So the building of the cars, the manufacturing of the cars, so can be done, all at once. Okay. We can get all the raw materials, all the fiber, all the rubber, or anything we need in one place, and we can just uh, do some, bending of the things or molding or melting of the things at one place, and we can just build the one car. Okay. So, but if the industry won't work like that, they're not going to dump all the raw materials in one place and they just do everything there one by one, right? So that industry that won't work like that. So they manufacture piece by piece. Like they manufacture piece by piece, and they would do the assembling. Okay, so the doors they'll be building separately. Okay, tires separate, the chassis separate, the roof separate. Okay, right, the mirror separate, everything. So each will be manufactured at different place, and finally in one assembling unit. So they will be doing that all that assembly. Okay, so for one part. So to be to be able to say let's come to DBT. So here also to be able to build one single model, so we can split the same model into multiple models and then finally make use of all those models to build our main model. Okay. So whatever are the CTEs, let's say, let's see our CTEs, different CTEs which we have used as different parts here. Whatever the customer models we have here, so that is our final product. Okay. So the splitting of, instead of using all the CTEs one query, okay, we can split those CTEs into multiple queries and finally assemble them to make our final model. Okay. So the concept of splitting our data or splitting our what models is what we call as modularity in DBT. Okay. So whatever the product, so which is kind of assembled, which is kind of coming from different manufactured products and assembling, so that we call as modular product. Okay. So here the modularity means, so we are just splitting our CTEs and making them into different models, and then finally we will be referencing them in the final model. Okay. So instead of using all the CTEs in one place, so we will just split them into models. So for what is the use of this modularity is, so let's say if you have some complex logic, so which is taking time, okay, so we can so you can just focus on making the query simple here, okay, because you'll be focusing on only one CTE at a time, okay, not this kind of simple CTEs. If there is any complex things you have to perform, so you can make this CTE into a separate model as of the CTE and in the other model. So this way you can make the CTE reusable. Okay, we can make this CTE reusable. So not only your model, not only the customer's model can use this. So if you require the same data in some other models also, you can just use the reference concept to make use of this same data. You don't have to write the logic again and again. Okay, is it clear?
Sir, in this example, final will be our the last query, means the
yes, the final will be our last query.
So can we use on top of this? Can we build by using this final as the reference? Means we can build the transformation in the model 2, right? Next
yes,
model.
we can do that.
We can use directly final. No need to.
No, you cannot use this this final. Okay, this is the CTE. So you can use this customer's model. Okay, this final select star from final is available in customer's model, right?
Right.
So if you want to use the data from this final in the other model, you have to use the customer's model. You cannot use this final. This is just a temporary object. Okay, this is the temporary data set.
No, in the second model, then which table you will do? You will means reference.
See, let me show you with an example. Okay, after that, if you have some doubts, we'll talk. Okay.
Okay, no problem.
Yeah. Okay. So anybody has any doubts here other than this? Okay. So what I'm talking about is splitting our one query into multiple models. Okay. So I want to split our customers CTE and order CTE into separate models and making use of those models in our customers model. Okay. So first, what I'm trying to do is I'll just create another SQL file. So I'll name it stage_customers. So from these customers, from our first model, so I'm just taking out this part. So and I'm putting here. I'm putting it here. Okay. So this will be my customers model with the same city which we have used. Okay. So I'm not doing anything here. I just lifted it from customers model and creating it as a separate model. Okay. Is it clear? So the same thing I'm going to do for the orders as well. So I'm going to create another file. Now I'm lifting the orders part here. Okay. Okay. For the same customers as well. So what I did here is, so I'm just remove the customers and other CTEs from the customers model, and I've created them as a separate model sheet. Okay. So this customers model will give us the reshaped data from the customers table. Okay. So using the whatever is coming out of from the select statement, so that will be the output from this stage customers table, and same like that. So orders CTE, this order CTE coming out of the orders table. So whatever the data is coming out of this order CTE, so that will be the output of this model. Okay. So this way, so see if you see here, so earlier these two models are available in the customers table itself. I mean in the customers model itself, right? So those queries are available directly in the customers model. So whatever the data that is coming out of that is correct, and that is what we want actually, right? But so if you make it this way, if you are just splitting the queries, if you are splitting that same query into different models, so now what we made is, so we made this customers logic what we have built as a reusable model. Okay. So now this stage customers is another model, right? So what we can do is .SQL. Just sorry. I did not add the .SQL extension here. I'm just trying to add that. Okay. So now what I did is, so I made the CTs into different models. Okay. Now these two models, stage customers and stage orders, are available for the other models as well. So other models which we are going to create in future, they also can use the same models. They also can reference these models so that they don't have to build the query or they don't have to write the query again. Okay. So they can just directly reference these tables and get the data from this. Okay. So this is one of the usage of the modularity here. So splitting up the model, splitting up the query into multiple parts. Okay. So now in the customers model, so we are just going to reference, we are just going to use the model, two models. We are just going to use the stage customers and stage orders table. Okay. So we are not going to write the query here. We are going to just make use of the two other models which we have created. Okay. Anybody has any doubts here? Okay. Now, so if we are going to use the stage customers and stage orders in customers model, so what happens is customers table will be dependent on customers and orders table. Okay, right? Because customers model should get the data from these two models. With the data coming out of these two models only, customers model is built. So what happens then? So we can call a customers model as a dependent model, right? So are you getting the point here?
Is it something like denormalizing and normalizing?
Oh, it's not like denormalizing. So we are just splitting the query into different models so that one logic which you have written so can be made reusable. Okay. So let's say in your normal queries,
Okay, you are
if
making
you want the
actually a
same data,
reusable code.
yes,
Sorry, Ravi.
reusable code. Right. Okay. So if you want the same data to be available in all your models, so instead of writing the same code, same complex code every time in all the models, you can just make that particular part of that code as a model. Okay. And you can just reference this model in your whatever the newly created model, you can just reference this model. Okay. That way your code looks simple. Okay. And it will not look that complex, and you are not wasting your own time writing on the same logic again. Okay. Is it clear? Okay. So now here comes another topic is called the ref functions. So which will be very useful. So whenever we are going to create a dependencies between the models, so we are going to use this ref function. Okay. So now I was talking about, using these customers model, stage customers and stage orders in the customers model, right? Now let's see how we can use those models by using the ref functions here. Okay. So I'll just be writing the same command. So I'm going to create another city here with customers as select start from. Now here, instead of writing the logic here, I'll just reference the stage customers model. How can I reference that? So open to curly braces, use ref, open the braces, and inside that you have to write your model name, stage underscore customers. Okay. So this is how you can reference your model. So if you see here, so earlier we have written this code. Okay, this code in the place of here, right? In the CT, we have written that code. Now we are not writing the code, we are just trying to do the referencing. Okay. The same thing for the order size. Okay, so this is how we can make use of other models. Okay, this is how we can create dependency between the models. Okay, so instead of writing the logic, we can just make use of other models here. Somebody is doubt.
Yeah, Ravi, like if at all the splitted code is in some other schema, like how do you call that? So it is mandatory that this code should be inside the same model or the same schema.
See here, why before you're creating this model, so here you have an option of changing your database or schema, right?
Mhm.
So while creating the
No,
models
but
itself,
can't we use this in that ref function?
which one?
That raw.jaffle shop, the fully qualified schema name,
See,
can't we
this
use
is,
it in the ref?
yeah. See, so this is our model, right? Stage customers is model. So inside our model, so we are making use of that table. Okay. So inside our model, we are just making use of this table. So in our main model, we are just referencing to the model. So by default, if you are referencing to the model means it will be directly referencing to this table itself, right?
Yeah.
So we don't have to use
Is it
this table name directly. We can make use of this model which contains the table name.
Oh, okay.
Right?
Even if it is outside some other model also, it can be called, right?
Yes.
Mhm.
See, now the customers is different model, stage customers is another model, stage orders is another model. Okay. Those three are three different models. Okay. In one of the model, I'm making use of the other two models.
Okay.
Okay.
Yes, Ravi.
So in one dot SQL file, can we create multiple models, or it will be?
What in one dot? What is that?
I mean, like in dot SQL file,
Mm-hmm.
can we create like a multiple models in one dot SQL, or we should have like each dot SQL for the every model?
I don't understand what is this one dot SQL.
I mean, if you are looking at your write the code with customers as, and again the row number 17 again is the customer underscore orders. Is it totally comes under the one model? Is it like a customers dot SQL or?
Yeah, see, this whole code comes under one model. Okay. The whole
Okay.
code comes under one model. Okay. Inside this code, we are just making use of other models. Okay. So right now we are developing the customers.sql file, right? So whatever the code, whatever the logic we use in that customers.sql file or the customers model, so that will comes as a one model only. Finally, customers.sql is the only one model. Okay.
Okay.
Single
Got it.
entity. That is a single entity. So inside that entity, inside that model, so we are writing some code. Okay. So inside that code, we are just referencing to the other models. So instead of writing this query, instead of writing this select statement inside the customer CT here, so I'm just writing the select star from statement. So earlier I had select ID, select first name, select ID, comma, first name, comma, last name from the customers. So that much query I have, right? So instead of writing that big query, I'm just using one single select statement. So that makes my code look simple, right? You're getting my point? So just for that reason, and one more reason is that, so whatever the model we have created with the existing city, so that can be made use in the other models. So let's say we have created some other fact model, not the customers model. If you want to create some fact model, okay. So in that fact model also, you can make use of this customers model. Okay. But earlier, what had happened? They said that CTU was inside the customer model itself, so that was not reusable. So that code can be made use only by the customer model. No other model can use that CT. Right now, we have made that reusable.
Sir, we have used this ref and referring the model in the other .sql file. So is it possible to join also the means whatever you are using ref? Is it possible for us to join with any other CT we are using below?
Yeah, you can do that.
Okay.
Yeah.
Okay, got it.
Yeah. So that is just whatever the data is coming out of that. So that just acts like a table name for us. So usually what we'll do here, we will be just giving instead of the ref, okay, we will be giving a table name or a view name, right?
And column names will be the same as the final.
Yeah. So whatever the column names are coming out of the stage customers, the same things will come if we use the ref also, the same output.
Okay, got it.
Is it clear? Is it clear about the referencing part? So let me just save this file. So, okay, fine. Then. So if nobody has no doubts, so we will just wind up this class. We will see how this reference function is going to work. Okay, in tomorrow's class.
Ravi, I have one quick doubt.
Yes,
Ravi.
yes, please.
I actually I came a bit late.
Okay.
My fundamental question is how much of Jinjas will be we will be dealing in this entire course? Do we really touch base with the Jinja codes?
See, earlier when we have planned this course, so we have not included Jinja. Okay, so because of some multiple requests, so we are going to include Jinja. Okay, here. So maybe at the end of all the fundamentals here, so we are going to deal with Jinja. Okay.
Okay.
So maybe if
how much of
how much of SM?
So what is that Jinja, sir?
See,
how
whatever
much of
yes.
That's a scripting in DBT, something like that.
Yes, this kind of things we use, right? So we are all the reference functions, the config blocks, So those are all can be called. So these kind of things, there are more kind of things. If you want to do some incremental things, we have to do. If you have to do some procedure kind of things, so there our Jinja kind of language will be used. So that is more native to DBT. The Jinja scripts is more native to DBT.
And this entire modularity is based on which language, Ravi, the structures and other things
So this is see the modularity which you can see here. So this is purely SQL. We haven't written anything
SQL,
here, right? Purely SQL.
Yeah.
Those are just
SQL
CTEs and select statements. So the only thing
Yes.
is while writing the Jinja, I'm just making use of the ref functions here. Okay.
Okay. The structure is also using a Jinja code background or just some.
No, in background there is no Jinja here. There is no Jinja format here. Okay.
Okay.
So this DBT is mostly based on Python, not on Jinja.
Python.
So, but whatever the code we are writing would be in Jinja or in the SQL. So eventually we will be writing the SQL statements. Okay. The base would be the SQL statements. Okay. So those SQL statements will be used by the Jinja script. Okay.
And what sort of SQL, Ravi, like a SQL Server or Oracle SQL or
you can say MS SQL. So most of the even if you see MPL SQL or MS SQL or Oracle SQL, so there would be some minor changes in the keywords, but all the functionality would be same for all the SQL.
Easily adaptable, right? We can easily adapt to that native SQL, whatever DBT is using.
So native SQL is, I can say MS SQL.
MS SQL, okay.
Yes. So if you know the SQL, okay. So adapting to any other SQL, like let's say if it is PL SQL or Oracle SQL, that wouldn't be much difficult. Okay. So the function names might change. That's it. Okay. So but everything would be same.
So you mean to say we can also use PL SQL codes inside
DBT? I didn't mean to say. I didn't mean to use that, but you can understand that. That's what I'm saying.
Okay. Thanks. Thanks, Ravi.
Okay. So if we are good, so we will just wind up this class, and tomorrow we will see how this ref functions, and we will talk about the dependencies. Okay. Okay, fine then. Yeah, thank you. Yes.
Thanks
Bye.
everyone.